Okay, so today we deal with the gas laws. Already we know the measurable properties of gases. So what are the measurable properties? So what are the measurable properties of a gas? Pressure, volume, temperature, mass in terms of number of moles. Okay. So now what are the gas laws means? The laws which relates these properties, the laws which gives the relations, nothing but the laws which relates these measurable properties of gases are known as gas laws. Okay, there is a different gas laws are present. First today now we discuss about the Boyle's law. Okay, so Boyle's law actually it gives a relationship between pressure and volume. It gives a relation between pressure and volume. So according to this law, at constant temperature, the volume of a given mass of a gas, the volume of a given nothing but a fixed mass of a gas is inversely proportional. Is inversely proportional to its pressure. Okay, now we see this is the simple definition. So at constant temperature, the volume of given mass of a gas is inversely proportional to its pressure. Means the volume is inversely proportional to its pressure, or pressure inversely proportional to a volume. It applicable only at a constant temperature. Now we see the explanation for this equation, and we see many graphs for it. Here V proportional 1 by P means in the place of proportionality we can write A is equal to constant K, that's by P. So now it becomes PV is equal to K. So PV is equal to constant. So this is also known as Boyle's law. So main Boyle's law equations means V proportional to 1 by P, or P proportional to 1 by V, or PV is equal to constant. Okay. So based on this equation, here for a gas at initial conditions, initially the pressure is say P1 and volume is V1. Okay, after some changes, its pressure becomes P2, its volume becomes V2. Okay, we are discussing only about one gas. Okay, according to this equation, we can write V1 equal to constant. Again, here also we can write P2 V2 is equal to constant. As the two belong to same gas, we can write P1 V1 equal to P2 V2. Okay, this is also one of the equations for Boyle's law, and we can write P1 by P2 is equal to V2 by V1, because both are inversely proportional. There is a P1 by P2 is equal to V2 by V1. That is exactly reciprocal to each other. Now we see some graphs for it. To know about the graphs, before we define one thing that is known as isotherms. So isotherms means these are the curves. The curves obtained plotting a graph between pressure and volume at constant temperature. Okay, the graphs, nothing but the curves or the lines, whatever it is, the lines obtained by plotting a graph between pressure and volume at constant temperature. So constant temperature ga general ga constant temperature ga తీసుకున్న అన్ని graphs ఏమంటామంటే isotherms అంటాం. Okay, now we see so many isotherms for Boyle's law. Okay, now we see the different graphs for it. So I can do, what is the Boyle's equation? So PV is equal to constant. So based on this equation, we are going to write the graphs. Nothing but V proportional to 1 by P. Okay. See the first graph. We are taking a volume on y-axis in terms of okay, liters, whatever it is. Okay. Now take the pressure on x-axis. So how they are related? Inversely proportional. So graph will be a curve like this. Okay. If you take the graph volume, pressure, so then also there is no change in its relation. It is also like this. Okay. Next, see the other one. Here we are taking pressure into volume. Here we are taking the term volume. So we know that PV is equal to always constant. As well as P inversely proportional means, for example, P increases, the volume decreases. If pressure decreases, volume increases. Means the product of pressure and volume is always constant. The product of pressure and volume is always constant. Okay, so volume change in there is PV is always constant. So PV is constant. Yes, in this graph here pressure is very small. X-axis pressure very small ga unnappudu volume ekkada undi very highest ga undi. As pressure increases, it right side pota undi ante avuthundi ikkada it down avutundi line. Means as pressure increases, volume increases. Ee particular point దగ్గర very high pressure, so ikkada daaka pressure తీసుకున్నాం. So very high pressure దగ్గర what is volume is very less. Okay, means this relates this equation, this relates this equation, so this relates this equation. And for the same graph we can write so PV versus pressure. So what will be the shape? Exactly straight line. Okay, because even by changing the pressure, the product of pressure and volume is always constant. This PV is equal constant. So this also represents this one. Okay, next. For example, pressure, volume. So x-axis by axis ekkada తీసుకున్న exact relation inversely proportional కాబట్టి no doubt. So it is like this. For example, so this curve indicates the relation is inversely proportional between pressure and volume. So ఈ టోటల్ ఏ ఎక్స్పెరిమెంట్ దగ్గర చేస్తే ఈ గ్రాఫ్ వచ్చిందంటే మనకి యాక్చువల్గా మనం ఎక్స్పెరిమెంట్ చేస్తే సో డిఫరెంట్ ప్రెషర్ దగ్గర డిఫరెంట్ వాల్యూ ఫైండ్ అవుట్ చేస్తాం. సో వాల్యూ ఫైండ్ అవుట్ చేస్తే డిఫరెంట్ పాయింట్స్ వస్తాయి, అంటే డిఫరెంట్ వాల్యూమ్స్ డిఫరెంట్ ప్రెషర్స్ దగ్గర డిఫరెంట్ వాల్యూమ్స్ కనెక్ట్ ఆ గ్రాఫ్ ఆ పాయింట్స్ మొత్తం కనెక్ట్ చేస్తే వీ విల్ గెట్ దిస్ టైప్ ఆఫ్ షేప్. అయితే ఫర్ ఎగ్జాంపుల్ ఈ ఎక్స్పెరిమెంట్ ఎక్కడ ఇస్తున్నాం, we done this experiment at T1 Kelvin. T1 Kelvin దగ్గర ఎక్స్పెరిమెంట్ చేస్తే you got this type of values. ఫర్ ఎగ్జాంపుల్ T1 అంటే 200 Kelvin తీసుకుందాం. If you done the experiment for same gases, అదే గ్యాస్కి సేమ్ గ్యాస్కి 200 కాకుండా 200 ప్లస్ నథింగ్ బట్ 300 Kelvin దగ్గర ఎక్స్పెరిమెంట్ చేద్దాం. Even by increasing the temperature, there is no change in the behavior of gases. Temperature increase చేస్తే గ్యాస్ బిహేవియర్ లో చేంజ్ రాదు కాబట్టి we will get the same type of curve. అదే inversely proportional. But what is the change at 200 Kelvin and what is the 300 Kelvin means just the position of the graph will be changed. Just graph ఇక్కడ వస్తుంది అంతే. Okay, next then ఏమంటున్నాం, say it is T2 Kelvin. Okay, so number మన ఇష్టం ఉన్నది ఇవ్వచ్చు ఇక్కడ. If you done the experiment at 400 Kelvin, for example, ఇంకా temperature increase చేద్దాం 400 Kelvin. So as temperature increases, there is no change in the behavior of gases. కాబట్టి సో ఇప్పుడు ఎక్కడ వస్తుంటే the graph is obtained here. Okay, so అంటే as temperature increases, the position of the graph changes, but there is no change in its behavior. Say it is T3 Kelvin. Okay, we must remember about this relation. In this T3 is very higher than T2 is than T1. So ఈ relation ఐడియా ఉన్నాం. T1 or T2 or T3 కాదు. ఫర్ ఎగ్జాంపుల్ ఇక్కడ A, B, C ఇచ్చిన. సో టెంపరేచర్ A అనుకుందాం. A is greater than, B is greater than C. సో ఆ పొజిషన్ బట్టి మనం ఫైండ్ అవుట్ చేయాలి. హైయెస్ట్ టెంపరేచర్ ఇది, లోయెస్ట్ టెంపరేచర్ ఇది. బాయిల్స్ లాలో లోయెస్ట్ గా ఉన్న లైన్ లో టెంపరేచర్, హైయెస్ట్ గా ఉన్న లైన్ హై టెంపరేచర్. ఓకే, సో ఇన్ ద సేమ్ వే PV versus volume graph. We know that it is a parallel line to the x-axis, value axis. For example, this is done at T1 temperature. Same, if you do the experiment for same gas at high temperature, so the same type of graph will be produced here. So what is the relation here now? The relation is T2 is greater than T1. మేము సింపుల్ మన బాయిల్స్ అలా గుర్తుంచుకోవాల్సి ఏంటంటే అది ఇన్వర్స్లీ ప్రపోర్షనల్. సో లైన్స్ మాత్రం పర్ఫెక్ట్గా టెంపరేచర్ ఇంక్రీజ్ చేస్తూ ఉంటే సో ఆ లైన్స్ పొజిషన్ కూడా పైకి వెళ్ళిపోతుంది. ఓకే, నౌ వి సీ సమ్ మోర్ ఐసోథర్మ్స్. For example, T on the y-axis. This is 1 by V on the x-axis. 1 by value. We know that P proportional to 1 by V. So, ippadaaka manam we done the graphs P and V. That is inversely proportional. But P is proportional to 1 by V. Already reciprocal chesa kabatti that is proportional. So here exactly we will get the graph like this. Sorry. And that will be a straight line passing through the origin. Okay, so this indicates if you write the V proportional to 1 by P, we will get the same type of graph passing through the origin. Okay, next so see the other isotherm PV and sorry. What will be the shape of the graph? So we know this one. If you do like this, what will be the shape of the graph? PV and value. We know that PV is equal to always constant. So the graph will be like this. Okay, because PV is equal to constant. So next. Here we know that PV is equal to constant. So apply the log. PV is equal to constant plus just we are taking K. So apply the logarithm both sides. Log PV is equal to log K. That is log P plus log V is equal to log K. Okay. Now log P is equal to log K minus log V. Okay, so now we draw the graph in terms of logarithm. This is log p on the y-axis. Okay, it is very important one. On the x-axis we are taking log v. So which type of graph can be expected? So ikkada log k manaki. Okay. Okay, on the x-axis, what we took log v. It is x-axis paina తీసుకున్నాం. So y-axis paina we took log p. Why? So generally we know the equation for straight line, that is y is called mx plus c. Okay, nothing but it is ikkada ee shape lo mana x first undi kabatti, so c first undi kabatti y is equal c plus mx, no change in it. Okay, ikkada y-axis paina emundi manaki log p. Okay, next on the x-axis log v. Log v. What is in the place of m? Okay, here m indicates about the slope. Okay, ఇక్కడ m ప్లస్ లో ఏముంది, యూ గోట్ -1. m ప్లస్ లో ఈ ఈక్వేషన్ లో మనకి -1 ఉంది ఇక్కడ. సో వాట్ ఇస్ ఇంటర్సెప్ట్ k? ఓకే, సో ద స్లోప్ ఈజ్ ఇన్ టర్మ్స్ ఆఫ్ నెగటివ్. ఇక్కడ స్లోప్ ఎంత మనకి, హియర్ ద స్లోప్ ఈజ్ -1. అంటే ఇక్కడ y is equal to mx plus లో x పక్కన ఎంత ఉంది మనకి -1. సో హియర్ స్లోప్ ఈజ్ -1. స్లోప్ నెగటివ్ లో ఉందంటే ఇట్ ఈస్ ఏ negatively sloped straight line. Negatively sloped straight line with intercept log k. So this is what is the slope? Slope of this line is equal to -1. Okay, next what is the intercept? So this is called intercept. Its value is equal to log k. Okay, so this is the logarithmic equation. Okay, take the graphs.